Let's look at some examples of where we're taking the derivative of functions involving logarithms. The derivative of the log base a of x is equal to 1 over the natural log of a, so whatever that base a is, times 1 over x. So here in this first example, the derivative y prime is going to be 1 over the natural log of 5, since the base is 5 in this case, times 1 over x. In the next example, we have the function f of x equal to 4 times log of x. In this case, we're looking at the common log, where the base is 10. Recall that when there's not a subscript indicated, then we assume that it is base 10, the common logarithm. So here the derivative is going to be f prime of x. The constant 4, we can just carry that along with us, times 1 over the natural log of 10, since it's base 10, times 1 over x. And we can write this as 4 divided by x times the natural log of 10, if we like. In the next example, we have more than just an x inside our logarithm function. Here we have y equal to log base 2 of 6x plus 11. So we're going to have to use the chain rule here when we take the derivative. Y prime is going to be 1 over the natural log of our base is 2, times 1 over, and typically we say 1 over x, but here we have more than just x. We have 6x plus 11. Alright, since we have more than just an x, we then need to take the derivative of everything inside the log function. So the derivative of 6x plus 11 is 6. So here our derivative then looks like 6 divided by 6x plus 11 times natural log of 2. In the next example, we have y equal to 6 to the x times log base 7 of x. So here we have a product, so we're going to use the product rule. We can think of 6x as our first function, f, and log base 7 of x as our g, our second function. So now using the product rule, y prime is going to look like, we have the first function, 6 to the x, times the derivative of the second. So taking the derivative of that is going to be 1 over natural log of our base 7 times 1 over x, plus the second function g, log base 7 of x, times the derivative of f, our first function. So the derivative of 6 to the x is natural log of 6 times 6 to the x. So there's our derivative. We can kind of condense this a little bit. We have 6 to the x divided by x times natural log of 7 plus log base 7 of x times the natural log of 6 times 6 to the x. The next problem, we have y equal to log base 8 of the quantity x cubed plus x. And in taking the derivative here, we're going to use the chain rule since we have more than just an x inside the logarithm function. So the derivative y prime is going to look like 1 over the natural log of our base 8 times 1 over x cubed plus x, since that's everything inside the logarithm function, times the derivative of the quantity inside the logarithm function. So taking the derivative of x cubed plus x is going to look like 3x squared plus 1. Alright, so there's our derivative. Kind of condensing this, we have 3x squared plus 1 in the numerator divided by natural log of 8 times x cubed plus x. Alright, the next example, we have g of x equal to x to the 7th divided by 4x plus 1. So here we have a quotient, so we're going to be using the quotient rule. So our derivative g prime of x then is going to look like, take the denominator, which is 4x plus 1, times the derivative of the numerator. So the derivative of 7 to the x is going to be natural log of 7 times 7 to the x minus the numerator, which is 7 to the x, times the derivative of the denominator. The derivative of 4x plus 1 is 4. And this is divided by the denominator squared. So 4x plus 1 squared. We could perhaps try to simplify this a little bit. We can factor out the 7 to the x in both terms. If we factor that out, we're left with a 4x plus 1 times the natural log of 7 minus 4 divided by 4x plus 1 quantity squared.